In this video, our objective is I can use area models and partial products to multiply two two-digit numbers. So this is expanding on our last video where we were multiplying by a one-digit number. Now we have two two-digit numbers. So let's look at our first problem as an example here. In the storage closet, there are 17 different types of paintbrushes with 23 of each type. How many paintbrushes are there? So this is a multiplication problem. We are taking 17 and we are multiplying it by 23 to figure out how many paintbrushes there are. So first, just like in the last one with the area model, we're going to break apart our factors or our numbers we're multiplying into their tens and ones. So 17 can be broken into 10 plus 7, and 23 is broken into 20 plus 3. Now we can come over to our area model and put those numbers in as well. So 20, we have 20 plus 3, and then we have 10 and 7. So now we are going to multiply, because remember in this area model, we're basically finding the area of this rectangle by finding the area of each individual rectangle and then adding them all together. So let's find the area of this space first. So if we have 20 across, 10 down, 20 times 10, 2 times 1 is 2. And then we're going to add our 2 zeros. 20 times 10 is 200. Okay, how about this one? 3 times 10. That one's easy. 3 times 10 is 30. Let's go down here to 20 times 7. I know that 2 times 7 is 14. Add a 0. And our last one, 3 times 7 is 21. For our next step, it says use the distributive property to find the partial products. Now, the distributive property is this idea that we can take each of the things we're multiplying and distribute them through and multiply them by each number. So like up here, I took 10 and I distributed it. I multiplied it by 20, and then I also multiplied it by 3. I took my 7 and I distributed it by 20, and I also distributed it to the 3. So down here, we're just writing what we did over here. We started with 10 times 20, and then we did 10 times the 3 ones, which is just 10 times 3. Okay, and we're going to add that to how we distributed the 7 through. So we started with 7 times our 2 tens, which is the same as 7 times 20. And lastly, we did 7 times our 3 ones. Okay, and now that gives us our partial products. Remember, partial products means a part of the overall product. All of this together is the overall product. Each individual rectangle is a partial product. So our 10 times 20 was 200, and we're going to add that to 30, add that to 140, and add that to 21. And when we put that all together, I like to write them vertically over here so I can stack my place value. Okay, so if we put that all together, we get 1, 3, 4, 5, 6, 7, 8, 9, 391. Okay, let's just do a couple more examples together. So if I have 65 times 31, I keep forgetting to go back to our estimating lessons. So I know if I estimated 65 rounded up to 70 and 30 rounded it down to 31 rounded it down to 30, I would get 70 times 30. So my estimate of 2,100, that's where my answer should be close to. And that will tell me if my answer I get in the end is reasonable. So let's use the area model to solve this problem. So we're going to start by breaking up 65 into 60 plus 5 and 31 into 30 plus 1. All right, 3 times 6 is 18, and bring over my 2 zeros. 5 times 3 is 15, add 1 0. 5 times 1 is 5, 6 times 1 is 6, well, 60 times 1 is 60. Okay, let's add these all together. our partial products, add them together, see what we get. Okay, so we have a 5. 6 plus 5 is 11. 8, 9, 10. 1 and 1 is 2. So our answer in the end we got was 2015, which is pretty close to our estimate of 2,100. So I think it's pretty reasonable. All right, one more. 19 times 42. Again, our estimate, when I rounded our numbers, I estimated this answer should be around 800. So let's break this up. I have 10. Let's find an exact answer. 10 plus 9 is 19. 40 plus 2 is 42. Now let's find our partial products. 4 times 1 is 4, and add your 2 zeros. 4 times 9 is 36, add 1 0. 10 times 2 is 20, and 9 times 2 is 18. Let's add these. Okay, and we get an 8. 6, 7, 8, 9. 4 plus 3 is 7. So we got the answer of 798, which is very close to our estimate of 800. So I think that is exactly the correct answer.